dear students, welcome to the lecture series on geography. In previous episodes, we discussed regarding the contents in the atmosphere. In this episode, we will concentrate towards the ocean water and their characteristics. There are many similarities between the atmosphere and the oceans. Both are composed of fluids, air or water which are free to flow under the influence of temperature differentials. Like the atmosphere has winds, so the ocean has currents. Just as the atmosphere has surface winds and upper atmosphere circulation, the oceans also have surface currents and deep water currents. In this lecture, we will examine the ocean water circulation and the reasons behind them under the following subheadings. They are density of ocean water, causes of ocean currents, Coriolis force and ocean gates, deep water currents and ocean currents and climates. Let us start with the density of ocean water. Water is most dense at 4 degrees centigrade. It expands when cooled below this temperature and when heated above this temperature. The oceans are heated from above. These two facts have important implications for ocean circulation. Because water becomes less dense when heated above 4 degrees centigrade, heating from the surface will form a warm, buoyant and stable layer at the surface. There is no tendency towards deep convection and mixing. Conversely, if water is cooled below 4 degrees centigrade, it becomes less dense, so a cold, buoyant and stable layers forms on surface. Water also undergoes a dramatic expansion on freezing, increasing in volume by 9%, so pack ice also forms a stable upper layer. Thus, in many circumstances, vertical motions of the oceans are suppressed. On the other hand, ocean water density is also influenced by salinity. The sea contains dissolved ions, mainly sodium and chlorine, and is consequently denser than fresh water. The salinity of seawater is rather variable. Evaporation at the sea surface will increase the salinity, whereas inputs from rain or river runoff will decrease the salinity. Salinity will also be increased by the formation of sea ice. As ice forms, salt is rejected from the freezing water, so the remaining liquid water is enriched in salt. The density of seawater is thus a combination of its temperature and salinity. Saline waters at around 4 degrees centigrade will be dense and will tend to sink, whereas warm, less saline water will be less dense and thus will be buoyant. This has important implications for vertical motions in the sea. Deep convection, whereby surface waters are transported to the deep oceans, is only possible where saline waters are cooled. To best understand ocean water dynamics or how water moves, there are a few simple principles to keep in mind. Water always flows down towards the lowest point. Water's density is determined by the water's temperature and salinity. Cold ocean water is denser than warm water. Water with high salinity is denser than water with low salinity. Ocean water always moves towards an equilibrium or balance. For example, if surface water cools and becomes denser, it will sink. The warmer water below will rise to balance out the missing surface water. Ocean layers. The ocean can be divided into several layers. The top layer of the ocean collects the warmth and energy of sunlight, while the bottom layers collect the rich, nutrient-filled sediment of decayed plant and animal matter. The top ocean layer is about 100 meters deep. Enough sunlight reaches that depth for organisms such as phytoplankton to carry out photosynthesis. Phytoplankton makes up the first part of the marine food chain and is essential to all ocean life. The middle or barrier layer is called the thermocline. The ocean's temperature and density change very quickly at this layer. The barrier layer is about 500 to 1000 meters deep. Below the barrier layer is the bottom layer, referred to as the deep ocean. It averages about 3 kilometers in depth.